All right, what is going on, everybody? This video, we're going to look at area under the curve, area between curves. Got several examples to work, so let's go ahead and get started. So let's start out with an example. Find the area bounded by y equals 2x squared, y equals 0, x equal 1, and x equal 2. All right, so whenever you're doing this, the best thing to do is sketch a picture. Now, you want to get the picture as accurate as possible, but you don't have to get all the little details of it. All right, so we've got 2x squared, so we know that's a parabola, and we know the parabola opens up like this. The vertex will be at the origin. Y equals 0, that's just the x-axis. And then we've got the line x equal 1, which we'll say that's about right here. This is x equal 1 and x equal 2. We'll call that right here. There's x equal 2. And we are looking for this area right here. All right, so to find the area, all we have to do is integrate. And so the area is equal to the integral of 2x squared dx. And we're going from x equal 1 to x equal 2. So that's 1 to 2. So that is going to give us, 2/3 x cubed from 1 to 2. And so that's going to be 2/3 times 2 cubed minus 1 cubed. And so that's 8 minus 1 is 7 times 2. That's 14/3. And there's your area. All right, so see, it's not bad. You just have to sketch your curve and then just integrate it from x equal whatever to x equal whatever. Okay. Now we will do some where we're going to need to do it with, instead of these limits on our integral being x values, they'll be y values, and we'll be integrating with respect to y. All right. So that example's coming up later on. All right. Find the area in the first quadrant bounded by y equals 9 minus x squared. All right. So we've got the negative in front of the squared, so we know that's a parabola that opens downward. The vertex is at 0, 9. And so there it is. And yeah, I mean, look, the graph does come this way too, and it does keep going down like this. But we don't need that. And why is that? Because they tell us all we want is the first quadrant here. You see that? The first quadrant. So that's the only part of the graph we need. And we know this is 0. And so our area is going to be the integral 9 minus x squared dx. Now, what's the limits on our integral? Well, we're going from 0 to whatever this is. And how do we find that? Well, this is when the function is 0, right? That's when the y value is 0. So we take the 9 minus x squared equals 0. 9 equal x squared. And so we get x is plus or minus 3. And so this is 3. And if you drew it over this way, this would be your -3. Okay. But we don't need that one because we're just going from 0 to 3. And so that's 0 to 3. And so we get 9x minus 1/3 x cubed. And that's from 0 to 3. And so this is going to be 9 times 3 minus 1/3 times 3 cubed minus. Now, let me show you this. I'm going to write it out and then I'm going to erase it. But we're plugging 0 in here, right? So that's 9 times 0 minus 1/3 times 0 cubed. Now look, you see all of this is just 0. Now, if it helps you to write this out like this, that's fine. But what I like to do at this point, since you've done plenty of these, all right, so we plug the 3 in. Now we plug the 0 in. This is 0, this is 0, so we know the whole thing is just 0. Okay, you can do it either way. As far as the students in my class, you can just put the 0 there if you want. And so this is going to be 27 minus, 27 minus 9. And that is going to be what, 18? All right. So that's the first couple of problems. So those are pretty straightforward. They're pretty easy. You're just, sketching it, integrating the function. Now, let's look at this. Here we have two curves, okay? We've got curve y1 and y2, and we want to find the area between them. Well, if you have two curves like that and you're looking to find the area between two curves, it's the curve on top minus the curve on bottom. See that? It's the integral of y2, which is the curve on top, minus y1, which is the curve on bottom. And that's what you integrate. Okay? And then here, notice how the curves, how they look different. This is one where we would integrate with respect to y. So if you have a curve, and we'll label this curve x1, we'll label this curve x2, then it's the curve x2, which is the curve on the right, minus x1, which is the curve on the left. All right, and we'll do an example of each one. Okay? All right, so let's look at this one. Find the area bounded by y equals x squared and y equals x plus 2. So let's make a sketch. And so here's x squared, okay? And then x plus 2, let's see, 1, 2, there's the y-intercept. Rise over run, so we go up 1 and over 1, about right in there. And so we are looking for this area right here. Now, where does this intersect? I mean, I just kind of went up 1 over 1, and this point may not be completely accurate. We'll know more when we figure out these points here where they intersect, because we've got to get those values. But like I said, all I'm doing, I'm just making a rough sketch of the graph to get some kind of an idea of what it looks like. Okay? All right. So the area, which is the curve on top. Now, do you see this area here? Let me highlight this in a different color. This is what we're looking for, the area between that. All right. Now, do you see how this curve here is on top? You see that? Now, you can see once you get out of this region over here, see this curve is on top, this curve's on bottom. Here, this curve's on top, this curve's on bottom. But in here, this curve, the x plus 2 is on top and the x squared is on bottom. So it's the curve on top, which is x plus 2, minus the curve on bottom, which is x squared. And we're integrating with respect to x. Now we need to get the limits on our integral. And so I need to know, where do these graphs intersect? Well, how do we know where they intersect? Well, that's if you set them equal to each other. And so we get x squared minus x minus 2 equals 0. And it's nice that it factors. Minus 2 plus 1. So x equal 2 or x equal -1. So that's -1 and 2. And so we're going from -1 to 2. All right, so this is going to equal -1 to 2, -x squared plus x plus 2 dx. Now, what did I do here? Well, all I did is I took these terms and I wrote them in descending powers. That's it. You don't have to do it. You'll get the same answer if you don't. I just like to do that. I like to write them in descending powers. So now let's integrate. So that's going to be -1/3 x cubed plus 1/2 x squared plus 2x, and that's from -1 to 2. And so that's going to be -1/3 times 2 cubed plus 1/2 times 2 squared plus 2 times 2 minus, and now we plug the -1 in, -1/3 times -1 cubed plus 1/2 times -1 squared plus 2 times -1. And this one, you would have to do some arithmetic on this, but you can punch it in your calculator and you end up getting 9/2 as an answer. All right, so hoping all of this is making sense. So let's come to the next problem. Find the area bounded by the curve y equals x cubed minus 3 and the lines x equal 2, y equals -1, and y equals 3. All right, so let's go ahead and sketch the graph. Now, just real quick over here on the side, we know that the graph of x cubed looks something like that. Well, we've got x cubed minus 3, so we know all that does is takes this graph and it shifts it down 3 units. So it's actually going to do something like this. Okay? And then we've got the line x equal 2, which that's going to be about right here. That's x equal 2. Because we know this, if you take x cubed minus 3 equals 0, x cubed equals 3, x equal the cube root of 3. And the cube root of 3 is less than 2, so we know it crosses to the left of 2. Okay? All right, so, and then we've got the line is y equals -1, which that's going to be this line here, and y equals 3, which that's going to be up here. So this is y equals 3, y equals -1. Okay. All right, and we are looking for this area here. Now, notice this problem. We're not going to integrate with respect to x. And why is that? Well, look at this. You see this curve here? You see how throughout this, and we're coming on down here, but throughout this shaded region here, you see the x values, they don't stay the same like they did in the other problems. See, like this problem, this x and this x, it doesn't ever change. You see how the y values change. See how this y value changes? This y value is increasing. Y value is increasing. But the x value here, the x value here, they're staying the same. So what we're going to have to do here is we're going to have to integrate with respect to y. And so remember, the area is going to be the integral, and it's going to be, remember, the function on the right, which is 2. X equal 2, right? 2 minus the function on the left. And that's this y equals x cubed minus 3. But remember, we have to get this in terms of y. And so this is going to be x cubed equals y plus 3. See if I move the 3 over. So x is equal to the cube root of y plus 3. And so this is going to be minus the cube root of y plus 3. And that's going to be dy. And we're going from -1 to 3. And so now we've got to integrate this thing. Now, to integrate this, well, look at this. We know the antiderivative of 2. That's just 2x. But what about this cube root of y plus 3? Well, we're going to have to use u substitution on it. So if you have several terms, you know you can integrate each term individually. But if one of them is, well, we know the antiderivative of 2, but this one we need to use u substitution, then what I would recommend doing is writing this as -1 to 3 of 2 dy minus -1 to 3, the cube root of y plus 3, but let's write it as y plus 3 to the 1/3 dy. Go ahead and split it up. Okay, that's what I would recommend doing. And so now we have -1 to 3, and that's 2 dy. Yes, I could go ahead and integrate it, but I'm going to just wait until I integrate this one before I do anything. So here we're going to do what? We're going to, we're going to let u equal y plus 3. So du is equal to dy. And so now we've got minus, and the y plus 3, we're going to replace that with u, and that's u to the 1/3. And then the dy, see the dy, we can replace that with du. And then remember what else we need to do. We're going to have to change our limits of integration, because see, we're changing to our variable being u. And so that's going to give me u is equal to 3 plus 3, which is 6, and u is equal to -1 plus 3, which is 2. So we're going from 2 to 6. All right, so remember that. We did that in previous videos, previous lessons. You learned u substitution and how to change the variable, or how to change the limits. And so this is going to be 2y from -1 to 3 minus, and I'll put this in a bracket, and that's going to be, let's see, u to the 4/3, and so that'll be 3/4 out here, and that's from 2 to 6. And so this is going to be 2 times 3 minus 2 times -1 minus, and then that's going to be 3/4 times 6 to the 4/3 minus 2 to the 4/3. And of course this, you're going to have to punch that in your calculator. And that's going to give you 1.713 as an answer. All right. So there's one where we had to integrate with respect to y. All right. All right, let's look at the next example. Find the area bounded by y equals x cubed minus 3x minus 2 and the x-axis. All right, so let's make a sketch of the graph. All right, so this graph is going to look something like this. And we are looking for this area right here. All right. Now, here we go. Now, I'm not going to show all my work on how I graphed it or how I get the limits, but this graph here, how did I know how did I know how to graph that? Well, it's because I typed the function into some computer software and copied it. That's how I knew how to graph that. And I know what you're thinking. Well, we're not going to have that on the test, and you are correct. So what do you do when you have something like this? Well, remember, what would you have to do on this one to graph it? You would have to find your critical numbers, increasing, decreasing, relative max min, concavity, inflection points. Yes, you would have to go back and do all of that to get this graph. Okay? Now, obviously, in my class, I wouldn't give you one like this on the test because it would just, it would just take too much time for you to work the problem if I had to do all that. All right, so that's where the graph came from. And now we need to get these x values where it crosses the x-axis. And that is going to be at -1 and 2. Now, how do I get that? Okay, so for that one, obviously this is not a quadratic. It's not going to factor. So for this one, you would actually have to solve this. I don't know if you remember where you find the factors of P and Q and do your P over Q and use synthetic division to determine if it's a 0 and you break it down. Okay? That's how you would have to solve this. So, and obviously I'm not going to do that on this problem. It takes a while to do that, to work those problems too. This problem just takes a while to work if you had to work everything out. But if you're not sure or don't remember how to do that, to solve that, you can search my channel, Solving Polynomial Equations using Synthetic Division. Look for that. I think that's what you would type. If I remember when I post the video, I'll put a link to one of the videos in the description. Okay, I've got several videos on that, but I'll put a link in the description for them if I remember to do it. If not, if I don't have the link there, somebody just comment on the video and say, hey, put the link on there. But yeah, it's a lot of work just to get the graph drawn and get your limits. Okay, all right. So now we've got the area is the integral -1 to 2. Now, this is the main thing of this problem. So what some of you may do is this, and put dx, and that would be incorrect. Okay, notice this area is below the x-axis. And do you remember what we talked about earlier, that it's the function on top minus the function on bottom? Well, what's the function on top? That's this right here. This is the line y equals 0, right? Isn't that function on top? And so that's going to be the function on top minus the function on bottom. All right, so that's what's going to happen when it's below the axis like that. So there you go. And so now that's going to give me -1 to 2, -x cubed plus 3x plus 2 dx. And so now I'm going to integrate. And so that's going to be -1/4 x to the 4th plus 3/2 x squared plus 2x, and that's from -1 to 2. And now we just plug everything in. That's going to be -1/4 times 2 to the 4th plus 3/2 times 2 squared plus 2 times 2 minus, and now we plug the -1 in, -1/4 times -1 to the 4th, plus 3/2 times -1 squared, plus 2 times -1. And of course you would need to, you can punch all that in your calculator, and you will end up getting 27/4 as an answer. All right. All right, so now I think we've got, yeah, this is the last one. Now watch this. Watch this problem. This problem's a little different than the other ones. I tried to get problems where, where we would you would encounter just about everything. So it says find the area between y equals x cubed minus x and the x-axis. All right, so first thing we need to do is draw us a graph. And so that graph, let's see if I can draw that a little better, is going to look like that. And we're looking for this area right here. All right. So, how do we do this? Well, first, we need to know our x values. Obviously, this is 0. Oh, and once again, you might be wondering, how did you know how to graph that? Well, like I explained on the previous problem, critical numbers, increasing, decreasing, relative max min, concavity, inflection points. All right. So, well, now this one, we could actually take the x cubed minus x, set it equal to 0, and that would be x times x squared minus 1 equals 0. So we get x equals 0 or x squared minus 1 equals 0. And so that's x squared equals 1, x is plus or minus 1. So that's -1 and +1. Now, the area, now what some of you may think to do is -1 to 1, x cubed minus x dx. Now, is that correct? No, it is not correct. If you integrated that and evaluated it from -1 to 1, you would get, this right here would give you 0 as an answer. And you can try it on your own. So what's the deal with this one? Well, let's look at this. Let's look at this area first. Notice as we move along the x-axis, as we're moving from -1 to 0, notice this curve is on top and y equals 0 is on bottom. But once we go from 0 to 1, see how the curve on top changes and the curve on bottom changes? So you would need to take this and split it up into two separate integrals. So it would be this one, that's going to go from -1 to 0, x cubed minus x dx, plus, and then we've got to add this area to it. And so that's going to be the integral 0 to 1, and that's going to be what? Now this is similar to the one we just worked. We're going to have to do 0 minus x cubed minus x dx, because see, this is the curve on top, this is the curve on bottom. All right, so there it is, and you know, right now I can feel what you're thinking right now. You might be thinking this, and for those of you that are, you would be correct. Yeah, this is a lot of work here. You know, I got two integrals to do, and this is how I'm going to work it. But let me show you this. This area here and this area here are the same, right? So we could just find this area here. In other words, just do this integral and double it, okay? So that's an option. I'm going to continue to work it out like this. And you might be wondering, well, why are you doing that? Well, because it may not be the case always that these two areas are the same. So you wouldn't be able to just do one of them and then double it. So if you can't just do one area and double it, what do? Well, you got to split it up like this. Okay? Doubling one area is not going to always work, but this right here will always work. Okay? And that's why I'm doing it. I'm going to finish working it like this. Because, I mean, if you can do this, you can do this integral and double it. So that's going to be -1 to 0 times x cubed minus x dx plus, and then that's going to be the integral 0 to 1, -x cubed plus x dx. All right. And so we're going to get 1/4 x to the 4th minus 1/2 x squared. That's -1 to 0 plus, and that's going to be, let's see, -1/4 x to the 4th plus 1/2 x squared. And that is going to be from 0 to 1. And so now look, let's just save a little writing here. When I plug the 0 in, that's 0. Okay, minus, and now I've got 1/4 times -1 to the 4th minus 1/2 times -1 squared plus, now let's plug the 1 in. So that's going to be 1/4 times 1 to the 4th plus 1/2 times 1 squared minus, and then look, when I plug the 0 in, that's just 0. And then when we punch all that into our calculator, we get 1/2 as an answer. All right. And that concludes the video. Now, you know, to me, one of the main things when you're doing this is sketching the graph. If you have a good picture of what it looks like, I mean, it should be easy to set up the integral. You just got to get a good picture of it so you can see it. But yeah, that's all in this video. And actually, I'm making this video. Our electricity went out. The power went out where I live. And it's hot in here. So I'm wrapping it up. Oh, look at there. Just as I told you the electricity was out, it just came back on when I was telling you that. Maybe I should have told y'all that sooner and it would have come on sooner. All right, but yeah, I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.